Yes.
Okay. Yeah. Hi, everyone. Welcome to the Cube for All session this week. It's a great week because AWS reInvent is happening. And unfortunately, I couldn't be present for the AWS event. So I thought, why not, put something together so that it benefits the community. So today I'm going to be talking about setting up a production-ready EKS environment. I know, like we have seen a lot of basic concepts in the past. We've gone through, how we can containerize, deploy, and manage workloads. And we have seen some of the basic concepts in the past. And we've also seen how to deploy distributed databases, and we've seen some complex topics as well. But today's topic is going to be even more complex. I'm just giving you a heads up because we are going to touch base on the infrastructure, and AWS has a lot of services that we must be aware of while we are provisioning a production environment. So let's jump in and see what I'm going to cover. Basically, the architecture of bringing up an EKS cluster and different types of access modes, how you must configure your subnets for different purposes, for different needs. How do you set up IAM roles, then application load balancers and OpenID connectors, self-managed node groups and certificate managers, and all of these finally put together. Is there an easy way to do it? All right, so this is the overall architecture of different components that we may need if we are setting up an end-to-end production-ready EKS environment. It starts with having a VPC, which is region specific, and within VPC is where your EKS cluster will be running. And within the VPC, you have different availability zones, and you have different private public subnets. So in a cluster, you can have multiple node groups. These are nothing but your node pools in Kubernetes. And each node group would either belong to a single subnet, or it can span across multiple subnets, right? And within each of these node groups is where your actual nodes would come up. And these are nothing but your EC2 instances with certain AMIs. By default, if you're using EKS console, it brings up an Amazon Linux based instances. But it's possible for us to customize and have our own machine images as well. And then if you need, you may want to provision your persistent volume. So there is a storage aspect to it. There is a lot of network involved in this, network configuration involved in this. So you can see like a lot of boxes crossing each other. So there are a lot of configuration that is required for each one of those. Now, once we have these subnets, then we have the route tables and the gateways to be configured in order to route the traffic in and out of these subnets. And we have security groups across the cluster, and for specific to worker nodes, you can have additional security groups. You can have KMS, which is going to encrypt your data. You have CloudWatch to know what is happening inside the API services, different levels of logs that you can gather. And once you have your cluster, there are additional configurations that you can have. If you want to have a more secure access to your environment, so you have your IAM-based access, which again, by default, EKS gives you an OpenID connector. So I'm going to talk about it in the next couple of slides. So what is an OpenID and how to use it? And then you have these ECR registries and SNS for sending your notification. And you have certificate manager for managing your SSL TLS certificates. So it is overwhelming because of the different components that are involved. And if you have to have a production environment, so you cannot compromise on any of these. So all of these are required for you to have a more maintainable environment, which can be shared across different teams. So which also means you have to set the IAM roles and policies in the right way. And there are certain best practices that you need to follow. So EKS provides the basic setup, right? So you have your VPC. So it assumes that you have a VPC and a subnet configured in a certain way so that you could just use them while you're provisioning your EKS environment. And then you can customize this. If you are familiar with these concepts, then you can go and customize your own node groups with your own configuration. So for that, you can make use of AWS cloud development kit, or your CloudFormation template. So there are Terraform based accelerator repositories which you can clone, and then you can extend. So there is a plugin for Terraform for configuring EKS. So there are really best laid out documentation on how to use it. But I can tell you that it's kind of overwhelming and complex unless we know all these concepts really well. Now, once we have these configurations, so we are actually going beyond these EKS clusters, because we need to now, as I said, we have to provision VPCs and subnets. We have to also create IAM policies and associate them with different services within AWS. Then we have to configure, if we are using a load balancer, then different configurations apply, and you have certificate manager. So there is, beyond what is there in the AWS console, we may have to do additional configuration, and we have to put all these pieces together. So first, let's take a look at the different access types. So what are these access types? So as you know, like Kubernetes has a master API server, and then you have different worker nodes. Now, if you have to access the master API server endpoint, then you can set different types of access for that. In an EKS cluster, you have three main types of access. So public only, right? So you can access your master endpoint through your from your public internet. And when you bring up your cluster, if you set it as a public only, you can access the APIs directly. Public and private. Now this is where you have endpoint is available outside, but there are restrictions on your other inbound access, and you have both a public and a private subnet for that. And if you are private only, then all your API access happens only within the private subnet. Now, this public only uses a public subnet. Public private has both a combination of public and private only is all within your VPC. Now, if you are associating this with your load balancer, then there are certain requirements on how many subnets you need to bring up. So in case of public, I mean, it assumes that you have some level of redundancy. So if it's public only, then you need at least 2 subnets. Public private, so in public private, you need at least 4 subnets, so 2 public and 2 private. And similarly for private only, we need 2 subnets. So we'll talk about the subnet configuration in a while, but just to give you a heads up, so there is a minimum number of subnets that you may want to bring up when you are using different types of access types. And this minimum requirement applies only when you're using your application load balancer. Otherwise, you can just start with a single subnet, and then you can get going from there. All right, now coming to the subnets, this is how you need to configure subnets. So if you're using all public, then you need to create a route table that will route the traffic, all the outbound traffic to OpenCIDR, which means it is going to allow all inbound and all outbound through a gateway, internet gateway. I'm sorry, I haven't mentioned internet gateway. So here, what I mean is you can route all the outbound traffic through an internet gateway, right? And you have to have an auto-assigned public IP for this case, right? And then coming to public-private, you have to have an outbound traffic routed through your NAT gateway, and all inbound traffic will be disabled. And in this case, there is no auto-assigned IP. And then in private, there is no route table at all, and there is no auto-assigned IP at all. But in case of private only, you need to create certain endpoints so that you can resolve and use some of the AWS services. So if you want to say, for instance, talk to STS or CloudWatch, then you will be using a domain name, and that domain name has to be resolved within the the VPC itself. So you have to create a few endpoints to resolve those domain names, right? If you have to talk to other AWS services. So there are certain mandatory endpoints that you need to create. And if you're using additional services, then you have to configure those endpoints as well. Now, coming to the application load, the load balancer, I will talk about the load balancer in a bit, but just I want to bring that to your notice that if you are using public only, you need to tag the subnets based on whether it is public or private. So if you are tagging a public only subnet, then you have to set the ELB role. If you are using public private, you have to set two roles. One is ELB, another is internal ELB if it is to route the traffic inside your network itself. And then for private, it is internal ELB. So when I say internal and ELB, you can have a load balancer to route the traffic within your private subnet, or you can also have it to route the traffic that is coming in from internet as well. So external facing ones are set to ELBs, and any internal traffic can be routed if it is set to internal ELB. Okay, so the next topic is about IAM roles for service accounts. So IAM roles, it gives you a certain access permissions on how a user can, whether a user is authorized to perform certain actions. Now, it not only applies to the users, even your AWS services need permissions. For instance, your EKS service or the master service or your worker service, worker nodes, APIs, kubelets, they all need certain permissions in order to interact with other AWS services. So for those kind of purposes, you can create an IAM role with certain policies and then attach it to these EKS services, right? So you can say, I want to assume a particular role, then I'm performing these actions, right? So in case of EKS master role and the node group or the worker roles, you can create an IAM policy and then attach it to a role and then say, you assume these roles when you are performing these actions. For ALB controller, I will be showing you what the ALB controller does. So it is an external entity. So we are going to route the traffic through an application load balancer using certain policies, and that is an external provider, and it has to be set up as a web identity based provider role. So I'll talk about it in a while. So the next one is on the user application. So even the user applications, the pods, the containers can have certain policies associated. So if you're creating an instance profile, it applies to an instance. So similar way, so you can have a profile for your pods and containers, but in this case, you are actually creating a Kubernetes service, and then you are going to associate that role to that service, right? So even there, it assumes that the pods or the services assume that role when it performs certain actions on AWS services. So even in case of pods and containers, you can associate an IAM role. Now, coming to the application load balancer and the OpenID connector. So what is an OpenID connector? So OpenID connector integrates your OAuth. It provides authentication, and it provides a connection between your OAuth authentication and IAM policy. So it kind of helps you to connect between these two, right? So for instance, if you are logging into GitHub, for instance, you do a single sign-on, right? So in that case, your GitHub is a sort of an OpenID provider, right? So the end user provides a single sign-on, which is a client, and GitHub has an OAuth application which authenticates that request, right? In the same way, like you can set up your own authentication provider as well, or reuse some of those authentication providers when you want to access your applications running on Kubernetes. For instance, there is an accounts management service running on Kubernetes, and you can access that using /accounts path in your web web URL. So as and when you access /accounts, you need a proxy to route, an ingress to route the traffic to this particular service. So the application load balancer does that job based on your your access endpoint, your route rules can be set up, and the application load balancer will route those traffic to that particular Kubernetes service. Now, when you want to authenticate that request, so you want that to be secure, then you have to look at OpenID Connector. So you want to first of all do a single sign-on to your OpenID Connector, and that generates some single sign-on token, right? And you can pass that token from your web application. You can pass that in your request. So, for instance, you can set the JWT token that is generated out of this, or the SSO token that is generated out of it, by default will be added to your headers in your request. And say, for instance, it will be set to X Amazon OIDC connector. If you're using OIDC, they have, like, Amazon has its own OIDC provider. So if you are able to make use of that, then it sets the headers automatically. So application load balancer will know that it is authenticated, and then you can, then it performs the validation, and then it sends back to the Kubernetes service. So in order to do this, the application load balancer has to be configured to say, okay, this is the OpenID connector, which is validating the request, and this is the traffic, this is the incoming inbound request URL, and I have to be using this OpenID connector for that. So there is a linkage between the OIDC and the application load balancer. So there is a whole lot of configuration that we need to do in order to make this work. So for instance, you will start with creating an OpenID provider in Kubernetes. And when you provision an EKS cluster, you would have seen in the management, in the EKS management console, it gives you a OpenID connector issuer URL. And using that, there are certain steps that you need to follow to get the thumbprint of that, the root CA, and then you have to configure that. So that's one set of things. So basically, you are creating a provider within your Kubernetes. You have to tag the subnets, saying whether you want to route the traffic internally or externally. So based on whatever I showed you earlier. And then you have to deploy a certificate manager, which would manage your SSL certificates. If your endpoints have to be on TLS and SSL based endpoint, so you need to have a certificate manager. Then you need to have a certain roles, because we are going to assume a role. Now, I talked about having the application load balancer making use of the OpenID configuration, and you can allow certain actions that application load balancer can perform. So you can set certain IAM roles and policies to that, and then you have to deploy your ALB controller and with a service account, and then you will annotate it with the OpenID information. So it's going to be a whole lot of configuration. So I would say maybe in the future discussion I can actually show you how this configuration is done. But what I am trying to drive here is that it is going to be a lot of configuration. So so we have seen the OIDC, we have seen the ALB, we have seen the VPCs and subnets. Now you can have your own self-managed sorry about that. Yeah, you can have your own self-managed node pools as well. So you would go with something like that when you want to have more flexibility. So if you're aware, like AWS has announced an AMI called, like, the machine images called Bottled Rocket. These are Linux-based open source AMIs. They are very lightweight, optimized for container deployments, highly secure, and they boot up really quick. Right? Instead of you waiting for minutes, this comes up in a few seconds. So Bottled Rocket is really lightweight. And if you want to really make use of these AMIs, or if you want to customize your own base images, and then add some security hardening, you can do that. And you can create, CloudFormation template with all this, like bringing up nodes with a certain instance profile with certain base images. And if you want to say run it on, instead of Intel, you want certain other AMD based machines, right? So you can configure all of those in your CloudFormation template, and then you can import that when you are provisioning a new node group or a node pool, right? So you can customize, and these are called self-managed node pools. But if you are doing this, then you have to also bring up your own auto-scaling groups so that your node groups can scale. So how you can do that, as I said, like you have to have your own CloudFormation template for it, and then you must define your own auto-scaling groups. So now moving on to the domain certificate manager. So this is where you can bring your own certificates. You can import them into your certificate manager. You can create or manage certificates from the domain manager directly. But once you have a certificate in the domain manager, you can use that certificate and reference that certificate in your Kubernetes services by in your ingress. In fact, it's your application load balancer, and then you can point to the ARN of your certificate that is managed by the domain manager. So it's again, if you see, there are a whole lot of things that are happening, and it's really complex. If somebody has to bring up a production ready cluster, then there is a whole lot of things that we need to do. And even with that, it doesn't stop there. Now we have to configure SMS, EKS, ECR registry, and on top of it, like, we have to define IAM policies in such a way that it is really fine grained, and we are doing the bare minimum that is required in order to make these services work. So the complexity is not just in configuring whatever I talked about, but also setting the right IAM policies. Like the last few days, we have been, spending a lot of time in taking a look at each of these configurations and seeing how we can limit access to the services, and how to define the IAM policies, and even if one service is assuming something, then what is the least privilege that we can give in order to make these services work. So it's going to take a lot of time, and while we are doing that, what happens now, there is a lot of focus on infrastructure, but there is also an application stack that needs to be containerized and deployed. So the whole project becomes a lot more complex. So what I'm going to show you now is what is that we can do in order to simplify this. And we know there is an infrastructure as code, which will help you to customize a lot of things. But what if there is an infrastructure as no code, right? So you have a UI, you just go and do whatever is necessary. Take just a couple of minutes to configure, and then get your entire production ready environment in a few minutes, right? So this is where we have been building solution, and this is where we see a lot of potential for us to go automate a lot of the configurations that I talked about, and simplify the whole provisioning and deployment. So this is our dashboard. So we've been talking about gopaddle in the past demos as well. But then today our focus is on onboarding cloud accounts and provisioning clusters. So we have created a quick start wizard for that. So if somebody is starting with modernization, be it your infrastructure or your application, you can choose one of these wizards. So this onboard cloud and clusters is going to onboard your AWS account, provision your EKS cluster, and configure all those things that I talked about earlier. And then the next wizard tells you how to start with your source code, generate Docker files, YAML files, even in fact, you can also generate Helm charts, and then deploy your application on EKS. And then finally, you see the automation of workflows, which auto-generates your Jenkins pipeline code, or Azure DevOps, or GitHub Actions or pipeline code, right? So today, let us just see how to onboard your cloud account. So this is our gopaddle API token. So each of the user who subscribes to gopaddle will have a couple of API tokens, and this is a default token, and you can use this to make API calls. So we are just listing the API token here, and then we have the cloud account. Now this is where we provide the cloud account ID, and then we have all these. Say for instance, I provide the cloud account ID, and it has a few steps that you need to follow, right? So this generates a script, and this script is going to create IAM roles for different purposes, right? And you can find out what IAM policies we have for each one of these configuration. So it's all very fine grained. You can take a look at it. You can review, and you can also customize this. If you're using Quick Start, you go with these policies. But if you want to do it by yourself, you have other ways of doing it. I'll show it in a minute. But we provide a few pre-baked IAM roles and policies. And we tag, when we are provisioning clusters, we tag all the resources that we are provisioning with the source as gopaddle. So for instance, if when you're setting up an elastic IP, right? I told you earlier, like you need to set certain public IPs, and we tag everything. So as source as gopaddle, right? So if you want to delete something, you need permission to delete those, and we will be restricting the deletes only to any resource that is created through gopaddle. So that way, it's really secure, and you can restrict it to a specific region, right? So all the resources are tagged, and the policies are based on the region and the tagging, right? And you can also add additional permissions if you want to grant access to create self-managed node groups, or you can have your own application load balancer. So different types of permissions apply for different requirements. And once you have selected your permissions that you want to do, you can execute this curl command in your local machine, and this is going to create a cloud account. It's going to create all IAM roles, policies, attach the roles, attach the policies to the roles, and it's going to create a few resources, and then it will also register AWS cloud account with gopaddle. So here you can see. So how will it know that it is your cloud account? So here you need to have your AWS CLI installed in your local machine, and you need to do a AWS configure. So we expect a few permissions to run the script. So this is like your admin user for your account. You can configure this, and you can revoke the permission for this admin user later. We are not going to use this admin user credentials anywhere else except for provisioning your, I'm sorry about that, except for provisioning your initial IAM roles and groups. So once that's done, you can revoke the policy. We are not going to use this admin user for anything else. Right, and then once you have this, you will basically it will create a cloud account, something like this, right? So it would create an AWS account, and then it will generate a IAM user, and it will register with gopaddle with the policies that I mentioned earlier. Once you have these cloud accounts, you can use that to provision the clusters. So for instance, you can create a new cluster, you can provide a EKS cluster, and then you can choose the cloud account that you provisioned, right? And then you can choose the kube version, and you can choose the public or private access types. You can enable application load balancer, and you can either use your existing VPCs, or you can create a new VPC at the time of provisioning your cluster. Now, gopaddle will create the VPCs subnets based on all the requirements that I mentioned earlier, and it will based on the type of the VPC you want. You can either have a public only, private only, or both public private. So it's going to create subnets based on your VPC requirements. And then this is the master role. So here, this would actually take you to the AWS console, where you can create your cluster role. We have not automated this, and because this actually is about creating a role, and if we have to ask, in fact, like if this user that is registered with gopaddle, we do not take any super user privileges like creating roles or deleting roles, because that would be asking for more. So we are not doing that. We leave it to the end user's responsibility to create the roles. So you can have another user or an admin user who creates these roles and adds the ARN over here, right? So when we do that, we have what we have simplified here is that we have created a CloudFormation template in order to create those roles. So you don't have to really do a lot of work, except for that the person who has the privileges can go create this cluster role and pass on the ARN to you, right? And you can provide the CIDR information here. So this is going to create subnets, 3 subnets with these CIDR ranges, right? And you can also enable your CloudWatch logs, right? And once we have this, then we have to create a node pool. Now, this is where you can choose whether you want to use a self-managed node pool, or you will go with the EKS managed node pool. The moment you choose a custom AMI, then it's going to create a self-managed node pool for you. And you can choose different types of architectures. You can also bring up GPU instances, right? So all of these require some customization, and we've made it totally seamless. So it's going to create a self-managed node pool for you. And you can give the pool name, minimum maximum count of your node pool size, and you can provide the disk size and the desired capacity. And here as well, you need to create a node role, and you can attach it over here. You can choose the different availability zones for deploying your workloads, and then just this. And you, once you provision the cluster, you have the entire setup in 20 minutes, because EKS takes almost 20 minutes to bring up the cluster. But the provisioning itself, the whole process of creating all this configuration itself takes only a few minutes, right? And in fact, for ALB, if you have ALB, I think this cluster would tell you the process. So it will first bring up the cluster, and then it will show you, the way to add your application load balancer. So if I click on this, it tells you the process. Again, we have a CloudFormation template that will create the ALB role. So you'll download, and so let me show you that. So I'll just download this and then upload the CloudFormation template. Right, so here I have to just upload a template, and I can choose the file that I just downloaded, and this will create a role that's required. Sorry. So this is the role that we just now downloaded, and then we can just go create the the role. So only a recommendation at this in the process is that if you can tag the CloudFormation templates. So while you're creating any role, even here, you can actually add the source as gopaddle, so that later, if you want to sort of filter all your resources based on the tags, you will be able to see the source, and you will be able to manage those easily later. So this will create a CloudFormation role, and then you have to provide the ARN here. And once you provide the ARN, and you will have an option to install it, and you will be able to bring up an ALB controller with all the OIDC configuration and everything seamlessly. Moving on to the domain manager. So we have an integration with domain manager as well, certificate manager as well. So you can, in fact, add domains, upload your certificate files over here, and then you can attach this to the certificate, AWS certificate manager. So let's take a look at one of the configurations that we have. Say, for instance, this is one certificate that we have, and the certificate has been uploaded through gopaddle. And you can go to the certificate manager and then add to AWS account. So when you do that, you can choose one of the regions, and then and then you can add to AWS account. So this is going to register with your AWS account, and then you will be automatically be able to use the ARN when you are deploying the applications, right?
I think Vinodni, you are using wrong domain. Maybe you can use Jenkins spec link that contains the required permissions.
Absolutely, yeah. So this is, for instance, so this is the one. You can see as soon as you add it to the AWS account, it generates an ARN number, and this can be used at the time of launching your application. So we have made this seamless. For instance, you can take an application template from here, and when you are launching it, you can provide. So let's say, I'm not very sure which is the distribution to use for this. So maybe I'll go with a different template. Yeah, so you have the image available in this. So let's say demo, and then you should be able to, if you are making use of the ingress, then you have the ingress load balancer, and this will automatically make use of the certificate that is available. So you can see the next stages. You will be choosing the domain that you want to use. So when you are using this domain, it will automatically add all those annotations in your ALB for deployments. So that's it for today. So this is the easiest way we could think of, because we have kind of automated all the complex configurations, and we can have your clusters, cloud accounts configured with the right set of privileges, and have the entire, the ALB subnet configuration and everything done just in a few clicks. I hope you enjoyed this demo, and if you really want to connect with us, want to learn more, please feel free to reach out to us, and I'm more than happy to help you in your projects. Right. So if you have any questions, you can ask me through LinkedIn, or you can also reach out to us. So if you go to our website, we have an interactive chat. You can connect through the intercom chat as well. Thank you so much for joining, and we look forward to talking to you in the next session. Thank you. Bye.